In the grand inventory of the cosmos, visible matter, baryons, is but a trace. We face the missing mass problem. Lord Kelvin and Henri Poincaré first hinted at this in the late 19th century, applying the virial theorem to stellar velocities. They found that the kinetic energy T was far too high for the potential energy V provided by visible stars alone. The smoking gun arrived with Vera Rubin in the 1970s. She observed stars at galactic edges moving at impossibly high speeds. Instead of the expected Keplerian decline, where velocity drops with distance, the velocity remained constant. This flat rotation curve necessitates a vast, invisible halo extending far beyond the luminous disk. Further evidence comes from gravitational lensing. Mass bends space-time, acting as a lens for background light. The deflection angle is directly proportional to the mass. We observe bending that requires mass far exceeding the visible cluster galaxies. The bullet cluster is the empirical proof. The collision separated the hot gas, interacting electromagnetically, from the collisionless dark mass. Could gravity simply be different at low accelerations? This is the premise of MOND, modified Newtonian dynamics. However, MOND struggles to explain the third acoustic peak in the cosmic microwave background power spectrum. Dark matter fits perfectly. So what is it? If not modified gravity, it must be a particle. Not MACOs, but something new. The leading suspect, WIMPs. Weakly interacting massive particles, heavy, stable, and produced in the early thermal bath. Remarkably, a particle with weak scale cross-section naturally gives the correct abundance, omega approx 0.27. This is the WIMP miracle. We search for them deep underground in vats of liquid xenon, waiting for a rare recoil. So far, silence. Another contender is the axion, born from the solution to the strong CP problem in quantum chromodynamics. Experiments like ADMX use strong magnetic fields to try and convert these light, wave-like axions into detectable photons. Neutrinos exist, but they are hot, dark matter, moving too fast. They wash out the fine structure we see in the universe. Cold, dark matter is essential. It provides the gravitational wells that allow gas to settle and form galaxies. Simulations like the Millennium Run, assuming cold, dark matter, match our observed large-scale structure with uncanny precision. It is the biggest gap in our standard model, a ghost particle that shaped our entire existence. We see its shadow everywhere, but the particle itself remains hidden. The hunt continues.